afternoon and welcome to this session of our track today. My name is Gianpaolo Bassi. I work for Dassault Systèmes SolidWorks. And today we want to present a very interesting design story that is very pertinent to the theme of the day, which is spaces. You have heard from the previous conversations, the panels that was before, that spaces are in a way products that we create. And as you know, at the Dassault Systèmes, we want to harmonize products, nature, and life, which is our value and our mission. Spaces are in various forms and shapes. City is a type of space that you can create and, as you know, influence our quality of life. Today, more than half of the population worldwide lives in cities. So reimagining, redesigning, and repurposing these spaces becomes more and more important. In addition to that, spaces organized in cities need power generation. So we need to make sure that the power that gives life, if you will, to the cities is created in a very sustainable way. Power generation often creates byproducts like heat that actually go wasted, including heating up the atmosphere around cities. People that use gliders know this very well. So we have today a guest, SolidWorks customers, an entrepreneur, a graduate of the prestigious ENSAM Paris University in 2008, that started a company called ENOGIA, that in 2015 won a prize at a competition that was awarded to him by Emmanuel Macron. At the time, was a minister, was not president yet. So I am honored to introduce Arthur Leroux. Please come on board. An applause. Hi, Arthur. Please.
Thank you very much.
Take a seat.
Thank you.
So Arthur is an expert of turbo machinery, which are engines that generate power in a very efficient way. So he has decided to apply this knowledge and the science of turbo machinery to the complex problem of generating electricity from heat. Heat can come from many sources, can come from geothermal, but his specialty is to reuse the heat that is a byproduct of other type of processes. Many industrial processes create heat that get wasted. So I think this idea of using the byproduct of industrial processes or even natural heat to transform it into energy using high efficiency machines is a wonderful idea, and the goal and his mission in life is to create spaces that are powered by more sustainable creation of energy. Arthur, please take the podium.
Thank you very much, Gianpaolo. This is very accurate, and I'm really glad to be here with you today and to be introduced by Gianpaolo, who did a very accurate introduction about what we do. So first, I'd like to show you a small video about what we do,
today,
and then
our world is facing challenges which
I'll say more.
Each and every one of us. Depletion of resources, environmental pollution, emerging technologies. Therefore, we need more available and cleaner sources of energy. We learned how to harvest the strength of water, of the wind and the sun, but it's not enough. Indeed, electrical production is responsible for 42.5% of the greenhouse gases emissions. What if there was another way to generate clean energy?
When we saw that huge amounts of heat are released into the environment every day, we thought that we had to do something. And by combining the latest state-of-the-art electronics and mechanics with the steam turbine principle, we created at ENOGIA technology that is very unique and allows you to convert heat into electricity, a useful energy.
Our goal is to deliver flexible and robust systems which can be integrated on a wide range of applications, like biomass, geothermal, or industrial process. Thanks to the compactness of our products, we can as well reduce fuel consumption of road and maritime transportation. Our pride is to see that our unique expertise, developed here in France with our engineers and technicians, is now well known all around the world and represented in more than 20 countries.
In Marseille, southern France, ENOGIA teams are creating machines that will change our way of producing energy.
Well, thank you everyone for listening to this short movie. Now you know a little bit about what we are and what we do. And I'd like to give you a few numbers just for you to have an idea about the size of the company. So we are basically a company which I founded with friends from the same engineering school and some Arts et Métiers Paris Tech in 2009. And now we have our head office and facilities in Marseille in southern France. We employ about 40 people currently. This number has been growing steadily over the last few years, and I will introduce to you just afterwards history of the company, because I think our story is quite original. So we have many references in many countries, but I show that to you later on. And we have two strategic partners which are very important to mention. One is our research partner, IFP Énergie Nouvelle, which is a French state-owned research group which helps us with improving our technology and bringing it to the transportation market. And our other partner is Faurecia Group, which is a tier one automotive manufacturer, and they invested at the beginning of last year into our company in order to strengthen our growth. So first thing, I like to introduce our history because I think it's quite funny and also interesting to know about. This is a short timeline of our story, but basically we were founded in 2009, and we won a few prizes in between. And so how did it start? So how this idea is born? So first, I was a young engineer, and when I graduated, I was very interested about UAVs. It was really my passion. I worked in my school project onto UAV, so I wanted to work in the military and UAV field. And so I did by starting at Bertin Technologies, which is a UAV engineering company close to Paris in France.
UAVs, for the audience, are unmanned.
Yeah. UAV is unmanned air vehicle. It's a drone, basically. It's in this case, it was a helicopter which can fly autonomously thanks to a computer. So it may sound very common now, but remember, this is 2009, 10 years ago, and it was not like it is today with many drones everywhere. Back then, drones were a new technology. Very often, it did fall. And when a big UAV falls, it can lead to big problems sometimes. So we had to work in this very innovative military environment. And it was really, really challenging and interesting as a young engineer. But at some point, I did enjoy my work, but I say to myself, what good does it bring? You know, what I am doing for the earth, for the people. And at some point, I wanted to do something more meaningful. I mean, UAV is important. It's used by the French armies, by the firemen to protect lives, but it didn't seem as meaningful as I wished to be. And in a weekend with some friends from the school, we had these very interesting discussions about our lives. We were working for a few years in different situations, and we were all a little bit disappointed, if I can say, about the work we were doing. My partner, for instance, was working in finance, and my other partner was working in engineering. So we wanted to do something different. And this weekend, in my small house near Paris, we say to ourselves, well, we have to change our line. This is not satisfying. We've been working for 2 years in this, and we need to do another thing. And we have this idea of bringing this technology which makes heat to power at a smaller scale. So in 2011, we did quit our jobs. I sold my house, and we said to ourselves, let's make something more meaningful. So we went to my partner's grandfather's holiday house. So it was basically a big house in the countryside of France, empty all year long. So my partner's grandfather lent this house to us, so we had no expenses and no living expenses except for food. And this was very useful because we were young engineers and we didn't have the financial means to actually build our technology. So with no expenses, we can afford to live and not spend too much money on living, so we can use all of our savings to build this very ugly thing. This is an extremely ugly proof of concept of our technology. However, the funny thing is that this ugly thing did actually work and produce some electricity. So you can see this was a shed where we built the prototype, and it was a really small shed. We couldn't even stand inside. And well, we spent 2 years working on this prototype, tuning it, finding some problems, but in the end we get it working. And then we said to ourselves, what do we do next? We have a proof of concept. We show that we can produce 2 kilowatts of power from heat by using this technology. What do we do? Back then, we weren't business school graduates. We were just engineers. So we weren't really comfortable with a business plan, with fundraisers, with all of that. So we went to see the business angels from our school. And because they are engineers, they knew our shortcomings in regard to business, but they also knew that we have a great idea. And so they did finance us. And with this fundraiser, we decided to make a real company by moving to Marseille, in a bigger city, closer to suppliers, closer to the business world. And that we did in 2012, at the end of 2012. So basically, we had this seed money from business angel, and we started working on actual commercial unit. We do a few first projects. One that you can see on the top right of the picture, which was in west of France. One other in China, in Nanjing. We did sell our first unit in Nanjing. And well, basically, at that time, there were 3 of us, then 4 of us, then 5 of us. So we basically had to do everything. So this picture is actually myself welding some pipes on the roof of a small container in a very not industrially friendly and safety friendly situation. You should not do that.
Don't do that at home.
But again, we managed to do a few projects first in China, then in Italy, then in France, then in Brazil. And our technology began to be a little more known. And then in 2015, we changed our office. We went to a much bigger place that you can see here on the top right corner, which is a little bit more better looking. And we started grow the business. Basically, we went all over the world to sell our unit. And actually, it was quite successful because our product was really compact, quite efficient, and very competitively priced. So we met quite a success in many countries. We started to sell in the UK. We started to sell all over France. We started to sell also in Korea, in China at that time. And so, well, you can see our workshop in 2016 being busier and busier by the day. Then the company growing, we were around 25 people. We needed more money to fund our growth. So we had to find another much bigger investor. Remember, we only raised up to 2017 only 250,000 euros of seed money. That's very low compared to our competitors that are in Germany, in the US, and in Sweden. So we had to find more money. And then we went to see the big industrial conglomerate because we saw that a partnership was more than just money, but also an opening to the much wider market of transportation. So that's when we did this fundraiser with Faurecia. Faurecia is a French tier 1 automotive manufacturer. It's a 140,000 people group, so it's a very huge company. And by raising this money, it allowed us to grow again the team. And by the end of 2018, we were around 35 people. And then what we do next? Our future definitely is in transportation. We have the most compact technology in this market, so we want to integrate this into the boats. It's fairly easy, it's quite big. Into the train, it's much more difficult. Into the trucks, and even one day into your personal car. That is our end target. Also, there are broad markets that we haven't reached a lot yet. In the left side of the picture, you can see a geothermal well in Iceland. This is a very interesting market for us, and we're definitely going into this market this year. So this is the story, basically, but you are all asking, well, you do sell machine which turns heat into electricity, but how is this even possible? Actually, so what do we do and how is this working? Actually, turning the heat into electricity is a very, very, very old idea. The Rankine cycle, which is used to produce the electricity which powers this light, like into the thermal power plants, was discovered around the 19th century. So it's quite old, actually. And the Organic Rankine Cycle also was discovered around the 19th century. What's new is not to make a Rankine cycle. What's new is to make it small, very small. So the Rankine cycle principle, I won't get too much into the technical details. We're free to speak afterwards. But basically the idea is to make a fluid boil and then turn this working fluid into electricity by using a steam turbine, a small steam turbine. So this is quite technical, but I'm really happy to discuss it with you later. What's specific about our Rankine cycle? That is that we make the most compact technology available in the world by using a high-speed steam turbine. High-speed turbine means that the shaft spins much faster than usual turbine. The big turbines that you may find in power plants spin at 1,500 or 3,000 RPM, which is quite slow. Our turbine rotates at several tenth of thousand of RPM. It spins very fast, and therefore it allows you to make it much, much, much smaller. And by making it very small on a single shaft with the turbine and the generator, you can make a very, very compact micro-turbine, and that is our technology, basically covered by 8 patents, and it's our core business. So with this micro-turbine, we have a range of products which produce electricity from 10 to 200 kilowatts. And these products, you can use it in many, many different applications. One is biogas, where you gather the heat from the biogas engine. One other is the solar, where you gather heat from the rays of the sun. You can use it in biomass as well, by burning wood, or in geothermal, by gathering heat from the water that comes from deep into the ground. But you can also use it and waste heat from the industrial factories, also from diesel genset and from all means of transportation. So with this concept, we sold this technology in many different countries. I'm not going to describe every one of these countries, but we're basically all around the world and we like it. Our teams are young, they like to travel, they like to install into many different countries. And these are a few pictures, so you can see that it's not yet for everyone. It's still an industrial product, but it's not also very big. It's not a very big power plant. We have some customers that are just farmers which invested into an anaerobic digestion plant, basically make electricity out of the farm waste, and we help them produce more electricity. So we have customers ranging from farmers to very big industrial groups. So how do we engineer these products? That's quite an important fit because right now having the correct tools and the correct skills for engineering such innovative product is a very important thing into our company. Our process is first to engineer a flow path. A flow path is the shape of the blades of the turbine where the fluid will be converted into mechanical energy and then will power the generator which will make the electrical energy out of it. So after we've engineered the flow path, we have then to test the turbine into strength by using numerical methods. And then we go to the proper mechanical engineering. Remember, we are turbine and mechanical engineer, so we use a lot of software for mechanical engineering. Then afterwards, we build the parts and we make the prototype and we test the small turbine. So this is our flow path. So where did the SolidWorks help us to improve our efficiency? Well, first, when we turned to SolidWorks, thanks to the entrepreneur program, it was really interesting because our engineers were used to use other softwares and they didn't want to change software. Everyone is reluctant to change. They have their habits. They know they are efficient on one software, so they don't want to change. But at some point, we had to change because our software were really not up to the task, because they couldn't engineer and do what they want to do with the software. So they started to use SolidWorks as part of the entrepreneur program. And a very interesting thing that they found is that it was very, very easy to learn. They were really happy. They were learning it into a few months. And I will speak of a project, a sample project for a young engineer. He started one day. He's never used the SolidWorks program before. And then in less than 1 month, he considered that he was fully operational on the software. And then afterwards, 1 month later, he finished the project. So in 2 months, he did a complete project, which is quite a big feat. So in this project, what he did, there was 3D drawing, obviously, of the machinery. Then also the detailed drawing. Then the assembly drawing, bringing every part together. Then the plans for manufacturing and all the manufacturing files. So only in 2 months. And I show you the end result. So this is the small turbine he engineered, and as you can see, it's quite a complex product because there's also 3D modeling involved, but also a lot of calculation, and doing this in 2 months, I think, is a very great proof of how efficient the software was. Because remember, 2 months earlier, he never used the software. So the main advantages for us are that it's a very simple and fast learning curve, and that's really important when you have to be productive, when you are a SME. You have to be really efficient when you change, and you cannot afford losing too much time. It's really ergonomic and with an intuitive interface, which makes it friendly to our engineers. They are happy to work with the tool because they like the interface. The strong customer support also was a really strong point. And thanks to the strong customer support, they were never locked into a hurdle, and they could call the customer support and go forward. And then there are efficient tools for modeling. As well, when you get to... Okay, so what's next? Obviously, SolidWorks help us improve our efficiency, but we are always looking for more efficiency as we grow, because the company is getting bigger and bigger, and we have to structure the company and have efficient processes. In the same time, our size changes a lot, so it's very difficult to handle. And a very important thing that we found out is that there was another program which is called 3D Experience Platform, and when we learned about it, we wanted to try. And so as a part of the Lighthouse program, we could try it. And this was a very interesting experience. And so what is 3D Experience Platform is a software as a service. So it means that you are able to use the software without having it locally in your computer. So everything is cloud-based for the storage of the data. So you use it as a browser window. And it's not just 3D design software like SolidWorks was for us. It's also a complete management and design based into a single tool. Another nice feature we discovered was a community feature, which allow different people working on this program to interact and exchange files, exchange tips. And this was quite efficient as well for the people, my engineer, who tried this program. So the main benefits, there is no powerful workstation needed, and this is a very big expense because you have to purchase expensive hardware to run the CAD programs. Instead, in 3D Experience platform, it's all software as a service, so there are big computers hosted by Dassault Systèmes, and you just need a simple computer to access the software. So you can access via internet from anywhere. So I shouldn't say that because in French law it's not very well liked, but our people can work home onto the project. That's very useful. There are internal and external exchange platforms. Internal meaning that our people can interact together, and external meaning that we can interact with other companies. As we have partnerships like with Foresha and IFPEN, it's very useful to exchange files and work together using this kind of service. We've not tried that yet, but we hope that we can do in the years to come. It's useful for the designer, but as you can have a full suite of software, the purchasing, the company manager, all parts of the company can benefit of this software. And lastly, it's quite economical because you pay only what you need as a software. You pay only the feature that you need and that you want. So this is a screen view of how it looks, like a browser window, and then my employee started to design this part, and he used the community help to build this part because he didn't know this software, he just discovered this software, and he found a part in the community, he modified it and used it to make this final result. And a few weeks afterwards, this is how looks the final result, which is quite satisfying. And so this proved to be a very efficient experience, and I hope that in the few years to come we can benefit more from this software. Thanks a lot. Thank you.
Thank you, Arthur. Very, very interesting. And I think we have a few minutes for questions. 2 minutes, okay? So, very, very interesting. We have questions from the audience. Let's give audience precedence. You.
Can I ask a very basic question? You're creating electricity via the turbines. Does it cost, is there any investment in any financial outgoing in running the turbines themselves?
Actually, when you purchase the product, indeed you have to pay for investment. But then with the cost of electricity, you get a very nice payback by producing your own electricity. So in most of the cases, the cost of electricity depends on where you are. But in most of the country where we sell our product, most of our customers get less than 3 years payback. So it's quite effective. And in some cases, it can go under 2 years. We are now also working on an energy service company offer, meaning that we will be able to offer a product not as investment, but as a service, the customer benefiting from the product and not having to invest. And we share the profit together with the customer. But this is quite new. Yeah.
So you need some level of heat, right, to generate electricity. What is this kind of level that you need to be productive, profitable?
Well, most of the time we try to bring this level as low as we can, because the lower you get into the level of heat in temperature, the more source that you can find. And currently we are very economically efficient and technically efficient above 80 Celsius of hot water. Basically, it means that our fuel is hot water at 80 Celsius. So it's quite low temperature actually to do power generation, and we hope that we can bring it a little bit lower in the next few years to come.
So you said that the source of heat could also be the sun. So how do you compare your technology with respect to photovoltaic, for instance?
Well, our technology won't match the photovoltaics in regard to pure efficiency and low cost. What is interesting with the Rankine cycle is that you use heat, and the heat you can store easily. So for the places that are very remote, you can use a heat tank, basically a big balloon full of hot water or hot oil, storage the heat from the sun, and then produce all day long. So we won't compare with photovoltaics. We won't go into the market where photovoltaic plants are tied into the grid, but into very remote places it can make sense.
I see. Very interesting.
So, good presentation, of course. Quick question. So, as you mentioned, this is a technology or the methodology has been there since 1900s. So, my question is, what makes you guys different and competitive? I'm assuming if this is really a way to go there, either because the technology is known, there are a lot of competitors. So why are you different and why are you sustainable compared to competitors?
That's a very, very good question. Basically, the technology was using an alternator connected to the grid and running at slow speed. And this technology has been around ages. We use it for producing electricity since more than 100 years. The big difference which allows us to make it smaller, well, there are two things. One is power electronics that allow us to turn high-frequency electricity into grid current, and power electronics have made great progress. And also there are some advances on the bearing and generator system which allow us to run the generator at like 50,000 RPM, and this was not possible before. The generator has to be wrapped in carbon fiber. There are a lot of technological breakthrough which allow us to make it spin very fast and then make it compact. If you cannot make it compact, basically you have to make a big plant. And so up to now, we couldn't make it as a compact product until we designed this technology.
And you have patents on these technologies? Nobody else can do it?
Yes, we have 8 patents, and these patents are owned as a partnership with IFP and this French institute.
Thank you.
Thank you.
Another question.
You say that the users, the engineers in your company learn very quickly how to use SolidWorks. What happened when you introduce and you ask the people to design on the 3D experience platform? How fast it was? How easy was it?
Well, actually, at first, like I said, people are a little bit reluctant. Engineers like to use the tools that they know, so they are not always willing to test. And when I convinced my engineer to try this 3D experience platform tool, he tried it, and I think in less than 1 week he was already feeling comfortable with it, because it's very intuitive and there's a lot of community-based help, and this community-based help is definitely something that is very efficient, I think.
Anybody else? So I will have one last question. I think I heard you right. At some point you sold your house to found the startup. Is that what you did?
Actually, that's not completely, I did say that, but that's not completely exact. I used my savings to fund the startup, but I sold my house slightly later on, and I didn't have any money from it because I had to refund the loan.
Okay. Okay, very good. So how was your experience in the startup world? What kind of advice would you give to young entrepreneurs like you to get out and take the risk and do something new that can make a difference?
Well, one thing for sure is do what you really believe and what you want to do. One other thing is get advice. We get advice from these business angels, and it was really, really helpful. And one last thing is I have to be very thankful because right now we are in the middle of European elections campaign, and I think the European Union helped us quite a lot. We were able to travel into multiple European countries, and this was definitely very helpful to grow our business, and we've been also helped by the European Union to do some research, so it was really a great benefit, I have to say.
Okay. Wonderful. Thank you very much. An applause to Arthur.
Thank you.